So the next one, in the expansion of 1 plus a the whole raised to m plus n, prove that the coefficient of a raised to m and a raised to n are equal. So what we have to do is we have to write the general term. Before writing the general term, we can write the value of a and b. What is a here? A is 1 and b is equal to here and a in this case, and the value of n is the power, which is n plus n. Okay, so general term is tr plus 1 is equal to ncr into a raised to n minus r into b raised to r. That's equal to n. What is n here? It is m plus n. M plus n c r. A is 1. So 1 raised to these two. The subtraction of the difference of these two. So m plus n minus r into b. B here is a raised to r. 1 raised to any number gives you the value 1 itself. So we are getting the general term as m plus n cr into a raised to r. And what is our question? We have to prove that coefficient of a raised to m and a raised to n are equal. Coefficients of a raised to m and a raised to n are equal. What is the coefficient of a? What is the term of a in the general term? It is a raised to r. Coefficient of a raised to m means here the term of a is a raised to r. And we require a raised to m. That means if this must be equal to a raised to m, the value of r must be equal to m. So to find coefficient of a raised to m, what to do is we have to substitute r as m. Okay, r as m. How we are getting m? Here the general term is m plus n cr. That means cr into a raised to r. So a raised to r, the coefficient of a raised to r is m plus n cr. We require the coefficient of a raised to m. So that is the reason why we are putting the value of r as m. So coefficient of a raised to m is equal to m plus n cm. We are just writing the coefficient, so no need to write a raised to m. So by combination, by the property, what is m Cn or ncr? It is m factorial divided by m minus n factorial into n factorial is the formula for finding the combination. So m plus n cn will be equal to m plus n factorial divided by m minus n is a subtraction of these two, isn't it? So here it will be m plus n minus m plus n minus m factorial into n is this value. So m factorial, which is equal to m plus n factorial divided by, here m and m minus m get cancelled, giving n factorial into m factorial. So what we get? Coefficient of a raised to m is m plus n whole factorial into n factorial into m factorial. Again we require one more coefficient. Which one? Coefficient of a raised to n. Coefficient of a raised to r in the general term is m plus n cr. So to find coefficient of a raised to n, we have to substitute the value of r as n. So we are going to find coefficient of a raised to n. A raised to n will be equal to, just to substitute the value of r as n. Okay, here it is coefficient of a raised to r m plus n cr. We require coefficient of a raised to n, so replace r by n. So what's the coefficient of a raised to n? It is m plus n cn. Okay, again we are going to apply the formula of combination, so which is m plus n factorial divided by m plus n minus n factorial into n factorial. M plus n minus n into n factorial, that's equal to m plus n factorial divided by, here n and minus n get cancelled, giving m factorial into n factorial. So this let us put as 1 and this let it be 2. Just check, we got coefficient of a raised to m as m plus n factorial by n factorial into m factorial, and the coefficient of a raised to n as m plus n the whole factorial by m factorial into n factorial. Both are same, isn't it? So what we can conclude from 1 and 2, coefficient of a raised to n is equal to coefficient of a raised to n.